What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
A mysterious interstellar visitor has just been spotted racing into our solar system, and scientists say it could change everything we thought we knew about space. A new interstellar object, moving at astonishing speed, has entered our solar system.
Some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all,
Sparking comparisons to the famous Oumuamua.
This object is simply a piece of another solar system that was expelled, and it has been traveling through interstellar space for hundreds of millions of years, billions of years, we don't know.
Discovered in 2017. Astronomers are racing to track its path, study its behavior, and determine whether it carries unique clues about the galaxy. While some theories remain speculative, one thing is clear. Each interstellar object reminds us how vast and mysterious the universe truly is. Let's take a closer look at what we know, what we suspect, and what this means for humanity's understanding of the cosmos. The discovery itself. The story of this new interstellar object begins with a faint point of light moving against the backdrop of distant stars. At first glance, it looked like countless other near-Earth objects astronomers routinely track. But as researchers followed its motion night after night, they quickly realized something unusual. The object wasn't bound to the sun in the way ordinary asteroids or comets are. Instead, its orbit was hyperbolic, meaning it was cutting straight through our solar system at astonishing speed, on a one-time journey from deep interstellar space. Early observations showed that the object was moving far faster than anything native to our cosmic neighborhood. While typical comets and asteroids follow predictable elliptical orbits shaped by the sun's gravity, this body came in on a trajectory that clearly originated beyond our system. By calculating its velocity and path, astronomers confirmed it was not a rogue rock knocked loose from the Kuiper Belt or Oort cloud. It was truly an interstellar visitor, a cosmic traveler from another star system. As telescopes focused in, scientists noted that the object's brightness shifted slightly, suggesting it wasn't perfectly round. This hinted at a shape that might be elongated or irregular, though not nearly as extreme as Oumuamua's cigar-like form. There were also early hints of faint outgassing, as though sunlight was causing small amounts of volatile material to escape its surface. This was particularly exciting, since detecting gas and dust could give astronomers valuable clues about its composition and whether it behaved more like a comet than a bare asteroid. The discovery itself was groundbreaking because it reinforced the idea that interstellar visitors are not rare flukes. For centuries, astronomers assumed objects from beyond the solar system might pass through, but only in modern times have we had the tools to detect them. With Oumuamua in 2017, and now this new object, scientists are realizing our solar system may be more like a busy cosmic crossroads than an isolated outpost. Each detection adds urgency to the effort of tracking, studying, and preparing for future interstellar arrivals that could reveal secrets of distant planetary systems. Comparisons to Oumuamua. Naturally, the very first question scientists asked after spotting this new interstellar object was, how does it compare to Oumuamua? After all, Oumuamua was the first interstellar visitor ever confirmed back in 2017, and it completely reshaped the way astronomers thought about what could wander into our solar system. Both objects share the critical marker of a hyperbolic orbit, meaning their paths are not closed loops but open-ended journeys, evidence that they came from far beyond our solar neighborhood and will never return once they pass through. That said, the differences are equally fascinating. While Oumuamua was famously elongated, resembling a cigar or possibly even a flattened pancake, depending on how light reflected off it, the new object doesn't appear to have such an extreme shape. Early observations suggest it might be more rounded or irregular, closer to what we expect from comets or asteroids. It also seems to show faint traces of gas or dust being released, something Oumuamua notably lacked, which baffled scientists at the time. Another major distinction lies in the way these objects move. Oumuamua demonstrated a puzzling acceleration that couldn't be explained by gravity alone, leading some researchers to speculate about exotic physics or even alien technology. In contrast, the newly detected object seems to follow a path more in line with natural expectations, at least so far. But astronomers remain cautious, knowing that more detailed data could yet reveal anomalies hidden beneath its high-speed trajectory. In the end, comparing the two is less about declaring one stranger than the other, and more about expanding our catalog of interstellar behavior. Oumuamua taught us that visitors from other star systems can defy our expectations, while this new object may provide a more typical example, or perhaps surprise us again in ways no one predicts. Each encounter deepens our insight into the building blocks of distant worlds and raises the thrilling possibility that our solar system is far from isolated in the grand architecture of the galaxy. Scientific reactions. The scientific community reacted with immediate excitement and urgency when the new interstellar object was confirmed. Astronomers around the globe quickly reallocated telescope time to capture as much data as possible before the object slipped away into the dark. The rarity of such an event meant there was no time to waste. Every observation could hold clues about the birthplaces of distant stars, the chemistry of alien worlds, and even the dynamics of how planetary systems form. For many researchers, this discovery was an opportunity to answer questions that had lingered for decades. One of the first reactions from planetary scientists was curiosity about its origin. By running simulations backward through time, teams began plotting possible trajectories to see which nearby star systems it could have come from. Some speculated it might have been ejected during the chaotic early stages of planet formation in a distant solar system, when giant planets tossed debris out into interstellar space. Others suggested it might be older than our sun itself, drifting aimlessly for billions of years before chance brought it here. Either way, the sheer possibility of tracing an object's history beyond our solar system stirred enormous scientific debate. Astrophysicists were equally fascinated by the object's physical properties. Was it more like a comet, shedding gas and dust as it approached the sun, or more like an asteroid with a hard, rocky exterior? The early signs of faint outgassing fueled discussions about exotic ices, perhaps hydrogen, carbon monoxide, or even more unusual substances that could behave differently from the water-based comets we are used to seeing. Some researchers argued this might provide evidence that other planetary systems form different mixtures of materials, broadening our understanding of what building blocks of planets can look like across the galaxy. Beyond the technical debates, there was also a sense of awe. Scientists compared the moment to the discovery of Oumuamua, noting how quickly the field of astronomy has shifted from speculation to observation. Just a decade ago, the idea of detecting multiple interstellar objects seemed nearly impossible. Now, with advanced sky surveys and rapid response telescopes, researchers realized that these visitors might be more common than expected. The reaction was about recognizing that humanity is entering a new era where interstellar material regularly comes within our reach, offering a direct connection to other star systems. Why interstellar objects matter? Interstellar objects are far more than just astronomical curiosities. They are time capsules carrying information from other corners of the galaxy. Each one has traveled unimaginable distances, surviving the violent processes of star formation, planetary collisions, and ejection from its home system. When they enter our solar system, they bring with them chemical and physical clues about environments we could never visit with current technology. Studying them gives scientists the rare chance to hold a fragment of another solar system's history, offering insights into how planets and stars form in places far beyond our own. One reason they matter so much is that they may help us understand the diversity of planetary systems in the Milky Way. Our knowledge of how planets form is largely based on studying our sun and its family of planets, moons, and comets. But interstellar objects are direct messengers from completely different systems. By analyzing their composition and behavior, scientists can compare them with the materials found in our solar system and see whether the processes that shaped Earth, Jupiter, and our comets are universal or unique. This helps answer some of the biggest questions in astronomy. Are we typical, or is our solar system unusual? There's also the possibility that interstellar objects could shed light on the origins of life. Some theories suggest that life's essential ingredients, complex organic molecules, may have been seeded on young planets by comets or asteroids carrying these building blocks. If interstellar objects contain such materials, it could mean that the potential for life spreads naturally across the galaxy, hitchhiking on rocky bodies expelled from one system and delivered to another. Finding organic compounds or unusual chemistry on one of these objects would strengthen the idea that life could emerge in many different environments. Finally, interstellar objects represent opportunities for the future of space exploration. With each new detection, scientists and engineers can refine strategies for intercepting them with spacecraft, potentially capturing samples or conducting close-up studies. Such missions would be groundbreaking, providing the first chance to examine material from another solar system directly. In that sense, these objects are scientifically valuable and milestones that push us closer to becoming an interstellar species ourselves, reminders that the universe is interconnected and that other worlds are not as unreachable as they once seemed. Possible explanations. When an interstellar object races into our solar system, the first question scientists ask is simple: what exactly is it? The possibilities are many, and each explanation carries its own set of mysteries. The most straightforward idea is that these objects are natural debris, chunks of rock or ice that were gravitationally slingshotted out of their original planetary systems. Much like our comets and asteroids, they could be leftovers from planet formation, ejected during violent collisions or close encounters with giant planets. If this is the case, every interstellar visitor is a free sample from a star system we may never be able to reach. Another explanation points toward comets specifically. Some astronomers believe these objects are frozen remnants of water, carbon dioxide, and other ices, wrapped in a crust of dust and rock. As they speed near the sun, solar heat might cause outgassing, jets of vapor escaping the surface that can change their motion in ways that appear puzzling at first. This was one of the leading theories for Oumuamua, which showed strange acceleration patterns that some thought couldn't be explained by gravity alone. If the new object displays similar activity, it could strengthen the argument that many interstellar visitors are simply exotic comets, behaving in ways we're not used to seeing. There is also the asteroid explanation. Unlike comets, asteroids are rocky and inert, without the volatile ices that produce tails and jets. An interstellar asteroid would be harder to detect since it wouldn't shine with the same dramatic outbursts as comets do. Yet if one is spotted, it could tell us a great deal about the rocky building blocks that form terrestrial planets across the galaxy. These asteroid-like bodies might reveal whether Earth-like materials are common in other systems or whether our rocky world is an outlier. Of course, there are the more speculative possibilities too. Whenever an object shows unusual behavior, like Oumuamua's cigar-like shape or unexplained acceleration, questions about artificial origins arise. Could some of these objects be fragments of alien technology, such as probes or derelict spacecraft? Mainstream scientists are cautious about such ideas, emphasizing natural explanations first, but the mere fact that the question is asked reflects how extraordinary these sightings are. Even if the answer is not extraterrestrial engineering, the oddities push researchers to refine their models of how interstellar debris behaves. In the end, each new interstellar object is likely a combination of familiar physics and new surprises. Whether comet, asteroid, or something stranger, The explanations force us to expand our understanding of planetary systems and keep the door open to possibilities we might not yet fully grasp. They remind us that the universe is both knowable and mysterious, offering puzzles that challenge our science while igniting our imagination. The physics of its speed. One of the most astonishing features of interstellar objects is their speed. Unlike comets or asteroids bound by the sun's gravity, these travelers move so fast that no planet or star in our system can capture them. The new discovery, much like Oumuamua before it, is racing along a hyperbolic trajectory, meaning its path is not closed like an ellipse, but open, ensuring it will pass through once and never return. This speed is a defining clue that the object originated beyond our solar system. The physics behind this incredible velocity starts in its home star system. Interstellar objects are often thought to be debris that was thrown out during the chaotic early years of planetary formation. When giant planets interact gravitationally with smaller bodies, they can act like slingshots, giving these fragments immense escape velocities. Once ejected, the object drifts freely through the galaxy, influenced only by the gravity of passing stars or interstellar clouds. By the time it arrives in our neighborhood, it is already moving faster than anything our sun can slow down. When such an object enters the solar system, its speed relative to the sun typically ranges between 20 and 200 kilometers per second, far higher than most comets and asteroids we track. What makes this speed scientifically fascinating is how it interacts with the sun's gravity. The object accelerates as it approaches, reaching peak velocity near perihelion, its closest point to the sun, before slingshotting back into deep space. This confirms its foreign origin, and also gives scientists a rare opportunity to test models of orbital mechanics at extreme speeds. Perhaps most importantly, the sheer velocity limits how long astronomers have to study it. A fast-moving interstellar visitor might only be within reach of Earth-based or space-based telescopes for weeks or months before it fades into the darkness again. This urgency pushes the scientific community to act quickly, mobilizing observatories worldwide and even considering rapid response missions to intercept future objects. The physics of its speed is both the signature of its interstellar birth and the reason our window to learn from it is painfully brief. The search for patterns and speculations. With 2 interstellar objects now detected in just a short span of years, astronomers are beginning to ask a profound question. Are these visitors more common than we ever imagined? For centuries, humanity stared at the night sky, believing the comets and asteroids we observed were all part of our solar system's closed inventory. But perhaps the truth is far richer, that countless wanderers from distant stars pass by us all the time, hidden in the darkness until our tools finally become sharp enough to see them. For most of human history, we lacked the technology to detect such small, faint, and fast-moving bodies. Oumuamua may not have been the first interstellar object, it was simply the first one we were capable of noticing. Its strange shape, its unusual trajectory, and the debates it stirred were not the beginning of the story, but the beginning of our awareness. The recent detection of another interstellar visitor strengthens this idea, suggesting that these cosmic messengers have been slipping through the solar system for eons, unseen and unrecorded. The coming decades promise a revolution in this field. Future surveys, especially those planned with the Vera C. Rubin Observatory in Chile, will scan the skies with a sensitivity and cadence unlike anything humanity has attempted before. Instead of missing these fleeting travelers, we may find ourselves cataloging them regularly. Some astronomers predict that we could soon discover dozens, perhaps even hundreds, of interstellar objects every year. If that prediction proves true, our understanding of the galaxy will shift dramatically. These will no longer feel like rare, once-in-a-lifetime encounters, but a steady stream of interstellar visitors offering fresh samples of other solar systems. Of course, with every discovery comes the danger of letting speculation run ahead of the evidence. The story of Oumuamua remains a perfect example. Theories of alien probes and advanced technology captured the public imagination, yet the simplest explanations, natural processes, ejection by gravitational interactions, or even unfamiliar types of cometary activity, still remain the most plausible. The lesson here is balance. Science advances by testing bold ideas, but it must always anchor itself in data rather than drifting into fantasy. And yet, even with sober analysis, the wonder remains intact. Because even if these are nothing more than fragments of rock or ice, they are fragments from light years away. Each one carries within it the chemical fingerprints of a different star, a different solar system, a different history of formation. To study them is to hold in our hands a piece of the broader galaxy, a tangible connection to places we may never reach with spacecraft. That, in itself, is extraordinary. The real magic lies not in imagining them as alien artifacts, but in recognizing that they are natural artifacts of the galaxy itself, reminders that our solar system is not isolated, but part of a much greater cosmic web. Looking ahead. For now, astronomers around the world are racing to observe this object before it disappears forever. Every night counts. They are pointing telescopes at it, measuring its brightness, analyzing its light, and mapping its trajectory. Space agencies are even discussing the possibility of planning future missions that could intercept such visitors, though for this one, it may already be too late. The key is preparation. If these objects are indeed common, then with enough warning time, humanity could send probes to meet them. That would allow us to study alien material up close, perhaps even touch it, and bring back samples. The discovery of this new interstellar object is a reminder of what's possible and of the incredible frontiers that still await us. So here we are again, watching the skies as another interstellar traveler speeds through our cosmic backyard. Is it just a piece of space rock, or could it carry deeper answers about life, origins, and the universe itself? Whatever the truth, one thing is certain. These fleeting visitors remind us that our solar system isn't isolated at all. It's part of a vast, mysterious, and interconnected galaxy. And the next discovery might just rewrite everything we think we know about the cosmos. Is this just another space rock, or the start of a bigger mystery? Comment your take and subscribe for more space updates.